Okay, let's give you guys some practice. Try to sketch this graph here. So remember, try and break it up something like this, and merge the x squared with the 2, because it's more accurate, and you're pretty good with drawing x squared minus 2, and this is one block here. So this x squared minus 2, remember this is a positive x squared. So this x squared minus 2 will look something like this. X squared will look something like this. X squared minus 2 will look something like this. Okay, and this bit here, 1 over x, will look something like this. And if you have minus 1 over x, it will look something like this. Hang on, it will look something like this. Okay, and this bit here, x to the power 3, it will look something like this. So the thing is, start by drawing yourself a graph like this. Ask yourself which term dominates when x is small. Is it this one here, or is it this one here, or is it this one here? One would dominate when x is small, and you have to follow the dominant one. And when x is big, if you put a big number, let's say 999, into each of these, which one would dominate? Well, one would dominate above or the other two. And when x is small, stick 0.000001 in here. Which term would dominate? Is it this one here? Is it this one here? Or is it this one here? And then, yeah. So, well, anyway, press pause and have a go at try sketching this. Okay, press pause and have a go. Okay, so start by drawing your graph here. The thing is, well, so visualize it as this, and we're going to merge these two together, and this block here. Which term dominates when x is really small? So like if you have x equals 0.0001, if you put this into here, and if you put 0.00 whatever into here, and then into here, the thing is this term would dominate because it's so much bigger. If you get a calculator and do hang on. Let's try and look at. You see, if you do this to the power 3, this is next to 0, next to nothing. Now, if you put this into here, 0.000001, a really small number, times by itself. I can't find the squared button, so I'm going to have to do it the long way. 0.0001 equals this, and then minus 2 it equals that minus 1.999 whatever. Okay, now if you put this into this term here, 1 divided by that, so clear this. Now we are now doing this, 1 divided by this really small number. So hang on, 1 divided by 0.001. Sorry. Let's start again. 1 divided by 0.0001 equals. You see, this number 10,000 is so much more dominant than this 2 here. You can pretty much forget about the 2. So you should be looking at this. When x is small, it wants to follow this graph here. So it will be something like this. Okay, really, it wants to follow this. But the thing is, as x gets bigger and bigger, it's not going to follow. It's not going to obey this. It's going to obey this. Okay, but when x is small, it will obey this. Yes, there's something happening in between here, but in comparison to this, when x is small, you can forget about this. And when x is big, you can really forget about this because it's going to obey x to the power 3. So you can forget about the middle part. So hang on, let's start again here. So let's look at this here. So we are going to look at it like this. When x is small, it wants to follow this. So your graph will look something like this. Don't forget, it's a positive reciprocal, so it will be like this. Okay. Now when x is big, it wants to do this. It wants to do this. That's what it wants to do. So you've got to do something like this. Okay, and then it wants to follow through here like this, and then down here like that. So now it's just a matter of joining up the two parts. See, so there. So your graph will look like this. So this weird graph will actually look like this. Okay. So now the moment of truth. Let's really plot this on a graph plotter. See what this whole thing here will look like. Okay. So hang on. So it will look like this. You see? Yeah. So remember, this is y equals x to the power 3. What was it? Plus x squared minus what was it? Minus 2 and then plus 1 over x. You see, when hang on, when x is small, which is around this region here, it wants to follow this bit here. That's why you've got this line here, and it wants to do that. And then when x is small, it wants to do this here. But the thing is, as x gets bigger and bigger, it wants to follow this bit here. So that's why it really wants to do this here. Goes through the origin and down here. It really wants to do that. Hang on, let me clear this. So when x is big, it wants to follow this. It really wants to do this through the origin and down here. But because when x is small, it wants to obey this. So it has to compromise. Well, anyway, so when x is small, it wants to do this reciprocal thing. And when x is big, it wants to do this. That's why you got to join up. You got to join up the two. That's why it looks like that. Okay. Find yourself a graph plotter and really plot this, and then you can see for yourself.